Hello everyone, let's look at grade 10 trigonometry, which contributes plus or minus 40 marks on your paper 2. So remember, your paper is over 100. So that means trigonometry alone is 40% of your paper 2. Here I am going to take you through some of the things that you need to make sure that you remember before you even enter the exam. So number one, you must be able to define your ratios. So you must be able to define your ratios in a right-angled triangle. Also, you must be able to define your ratios in a Cartesian plane. So let me start with a right-angled triangle. So if we have a right-angled triangle, here is our triangle ABC. So angle C is 90 degrees. So that means AB is our hypotenuse. Remember, hypotenuse is always opposite to 90 degrees. So this is our hypotenuse. Now, you must be able to define sine. Sine angle theta. So sine angle theta, the definition of sine is opposite over hypotenuse. So if the definition of sine is opposite over hypotenuse, so now from angle theta, which side is opposite? Remember, I am checking from angle theta. The side that is opposite from angle theta will be AC. So that means sine theta or sine of angle theta is the same as AC over the hypotenuse side is AB. Now, let's move to cosine of angle theta. Cosine of angle theta or cos theta is adjacent over hypotenuse. So from angle theta, which side is the closest? That is the adjacent side. So if I'm from angle theta, the closest side to angle theta is BC. So that means if this is adjacent over hypotenuse, it will be closest side is BC over what is our hypotenuse. Our hypotenuse is AB. And then we also have tangent. Tangent of angle theta or tan theta. So the definition of tan is opposite over adjacent. So from angle theta, my opposite is AC. So if I say this is opposite over adjacent, it will be AC over, from angle theta, my adjacent, the side that is closest to angle theta is BC. So it will be over BC. So that is your tan of angle theta. Now, you need to note that if you are looking for, let's say you are looking for sine, but your angle is no longer theta now, it is 90 minus theta. So if you are looking for sine and then 90 minus theta, remember again, what is the definition of sine? So the definition of sine, it is still opposite over what? Over hypotenuse. But now, if you are checking from 90 minus theta, so here is 90 minus theta, this angle there, and then from that angle, the side that is opposite, it is no longer AC. From 90 minus theta, the side that is opposite from that angle, it is BC. So sine 90 minus theta will be what? Will be BC, which is the opposite from that angle, over my hypotenuse here is what? My hypotenuse is AB. And then if you are looking for a cosine, if I am looking for cos 90 minus theta, the definition of cos is still adjacent over hypotenuse. But from angle 90 minus theta, the side that is closest to that angle, my adjacent side, is AC. So your cos 90 minus theta will be AC over, what is the hypotenuse? The hypotenuse is AB. You also need to remember your Pythagoras theorem. So in a right angle triangle, you also need to remember your Pythagoras theorem, so which says the square of the hypotenuse, so that is AB squared, is equal to the sum of the squares of other two sides. So AB squared is equal to BC squared plus AC squared. Now, let's move to defining ratios in a Cartesian plane. So let's define the ratios in a Cartesian plane. So you must also be able to define all these ratios in a Cartesian plane now. Here is our Cartesian plane. So they can give you a point here. Let's say you have point P, which is always X and Y. So if you have X and Y there, that simple means here you have your X, and then there you have your Y, and then here you always have your radius, which is your R. Now, using a Cartesian plane, the definition of sine. So sine theta is always opposite. My opposite is Y over hypotenuse, which is R. So sine theta is Y over R. And then cos theta is always the same as adjacent, X over R. And then your tangent, or your tan theta, is always the same as what? Is always the same as Y over X. So these definitions, you need to know them by heart. So do not go to the exam without knowing these definitions. Make sure that you know them, and then you will pass your trigonometry. And then in grade 10, we also have reciprocals. So you need to know reciprocals as well. So there is reciprocal of cos, there is reciprocal of sine, there is also reciprocal of tan. Now, let me start with the reciprocal of sine. So cosec, we also have cosec in grade 10. Cosec is the reciprocal of sine. So cosec is the same as 1 over sine theta. So now remember we said sine theta is opposite over hypotenuse. So if cosec is a reciprocal, so that means cosec theta is the same as 1 over sine theta, which can be written as hypotenuse over opposite. So you just invert the ratio of sine theta. So cosec is the same as hypotenuse over opposite. We also have the reciprocal of cos. Reciprocal of cos is secant or sec. Sec theta is the same as 1 over cos theta. So this is the reciprocal of cos. So that means sec theta is always the same as hypotenuse over adjacent. And then we also have cot. So cot is the reciprocal of tan. Here is our cot. It is the reciprocal of tan. So if cot is the reciprocal of tan, that means it can be written as, remember tan is opposite over adjacent. So that means cot will be adjacent over opposite. Cot will be adjacent over opposite. All right. You also need to remember special angles here. So with special angles, if you do have a K-show, I don't think you will have a problem with special angles, because K-show will always give you special angles. But please, when you are working with special angles, the answer that you will get from Keisho, do not take that answer to decimals. The answer that you'll get from Keisho, do not take that answer to decimals. Now, to work with special angles, we can say this is 0, 1, 2, 3, 4, and we start the process again. We can have here 0, 1, 2, 3, and then 4. Now you can put a square root in everything. So you put a square root here, you put a square root. You see, I put a square root in everything here. So now if I put a square root in everything here, now this is the same as, what is the square root of 0? This is the same as 0 and 2. What is the square root of 1? This is the same as 1 and root 3. What is the square root of 2? It will remain as square root of 2. This will also remain as the square root of 2. And then this will be the square root of 3 and 1. And then the square root of 4 is 2. So here you are going to have 2 and 0. Now, this one here, this distance here represent your r. So this distance here, or that one there, represent your r. So that means your r here is always equal to 2. So r is equal to 2. So let's say, for example, you are looking for sine 30. If you are looking for sine 30, remember this point here. Okay, if you are looking for sine 30, sine, remember we said it is y over r. So here is the terminal arm for 30. Here is the terminal arm for 30. So now that means sine 30 is equal to, what is y here? Y is square root of 1, which is the same as 1. So it is 1 over our r. We said it is 2. Let's say, for example, we are looking for sine 60. So sine 60 is equal to, still, this is y over r. So where is the terminal arm for 60? So here is the terminal arm for angle 60. What is y here? Y is the square root of 3. So it will be square root of 3 over r. We said it is always 2. Let's say, for example, we are looking for tan 45. If we are looking for tan 45 degrees, tan 45 is equal to, so where is the terminal arm for 45? So here is the terminal arm for 45. Remember, tan is y over x. So what is y here? Y is root 2. So it's root 2 over, what is x? X is also root 2. So it is root 2 over root 2. So tan 45 is the same as 1. So I'm not going to take you through all special angles. If you do have a Keisho, you will always get these answers. But in the Keisho, these answers are always rationalized. So the answer that you will get from Keisho, they are 100% correct. So, but you need to remember all special angles. Remember, special angles are 0, 30, 45, 60, even 90. So these ones, you need to know them by heart. So let's say, for example, again, we are looking for sine 90. So if I'm looking for sine 90 degrees, so the terminal arm for 90 is this one. Here is angle 90. So remember, this is y over r. So here, what is your y? Your y is 2 over, what is your r? We said r is always equal to what? R is always equal to 2. So sine 90 is 2 over 2, which is the same as what? Which is the same as 1. So that means without a calculator, you can find sine 90, even cos 90, and so on and so on. And then now, Let me move to quadrants, and then from there we are going straight to past question papers where we will be doing questions. All right, so now you also need to remember that we have 4 quadrants here. So we have the first quadrant. So in the first quadrant, our angle theta is from, so our theta in the first quadrant, theta is from 0, or is between 0 degrees and 90 degrees. That is the first quadrant. And in the first quadrant, all ratios are positive. So if I'm in the first quadrant, that means sine, cos, and tangent, they are all positive, even they are reciprocals. In the first quadrant, all ratios are positive. We also have the second quadrant. So in the second quadrant, this is the second. In the second quadrant, the only ratio that is positive, obviously with its reciprocal, it is sine. The only ratio that is positive in the second quadrant, it is sine. So remember, sine goes with cosec. So that means if sine is positive here, even cosec is also positive. And then in the third quadrant, here is our third quadrant. So in the third quadrant, the only ratio that is positive is tangent. So here, the ratio that is positive is tangent. So obviously with its reciprocal. So that means even cot here, cot of angle theta is also positive in the third quadrant. And then in the fourth quadrant, the only ratio that is positive is cosine. Obviously with its reciprocal, which is what? Which is sec. So, and again, remember, R here, we know that X is positive here, Y is also positive in the first quadrant. Here, Y is positive, but X is negative. Here, Y is negative, even X is negative. And then R is always positive. And then in the fourth quadrant, X is positive, but Y is negative. So now let's go straight to exam question papers and see how can we collect this plus or minus 40 marks. We need to collect everything in trigonometry. We need to collect everything. Now, let's look at exam typically questions. So question number 1. In the diagram below, triangle ABC is a right angled at B. So that means here at angle B, the angle is 90 degrees. We are given a right angled triangle. Complete the following statement. So now, question number 1 here, we are given sine of angle C. So now from angle C, okay, from angle C, here is angle C. So you need to remember the definition of sine here. What is the definition of sine? It is opposite over hypotenuse. So from angle C, my opposite is what? Is AB. That is why we have AB over, what is the hypotenuse? Remember, hypotenuse is always opposite to 90 degrees. So my hypotenuse here will be AC. So the answer here will be sine angle C is equal to AB over hypotenuse, which is AC. So the answer here is AC. And then question number 2. We are given angle A. So from angle A, we have now AB over BC. Now we need to check here. So now from angle A, let me check AB. So from angle A, I can see that my AB from angle A is adjacent. So this side represent adjacent from angle A, and then BC from angle A is opposite. So this one represent opposite. So now we have adjacent over opposite. So we can see that this is cot. So remember, cot is the reciprocal of tan, and tan of an angle is what? Is opposite over adjacent. Now, if I have adjacent over opposite, it is a reciprocal of tan, which is what? Which is cot. So here we have cot A. So cot A is AB over BC. And then we are done with question 1. Let's move to question 2. Question 2. Triangle PQR. So we are given a triangle PQR and triangle SQR are right-angled triangle as shown in the diagram. So we are given PR is equal to 26. We are given a PQ is equal to 24. We are also given a QS is equal to 8. We are given QR is equal to 10. And then we are given angle PRQ, which is equal to theta. Now, refer to the diagram above. Without using a calculator, write down the value of the following. So question number 1, tan of angle P. So now if you check from angle P, so here is angle P. You need to remember the definition of tan. What is the definition of tan? Tan is the same as opposite over adjacent. And then now from angle P, we can see that opposite is what? Is 10 over, and then the adjacent side from angle P is 24. So the answer here will be 10 over 24. You can then simplify it if you want to, but 10 over 24 is correct. And then let's move to the next one. Okay. So the next question here, we are looking for sine of angle SQR. So let's check angle SQR. SQR. So here is an angle. Here is angle SQR. So from angle SQR, we need to remember the definition of sine first. What is the definition of sine? The definition of sine is opposite over hypotenuse. Now, from that angle, we can see that the opposite side is equal to 6 divided by the hypotenuse. Remember, hypotenuse is always opposite to 90 degrees. So my hypotenuse will be 10. So it will be 6 over 10. Okay, let's go to the next question. In the next question, we are looking for cos theta. So what is the definition of cos? The definition of cos is adjacent over hypotenuse. So the definition of cos is adjacent over hypotenuse. Now, from angle theta, which side is adjacent? So here is your adjacent side. And then which side is the hypotenuse? So the hypotenuse will be opposite to this 90 degrees here. So it will be 26. So here we have our adjacent as 10 over, and then the hypotenuse is 26. And then lastly, we are looking for sec and then of angle SRQ. So now first, let's check where is angle SRQ. Okay. SRQ. So we are talking about this angle as a whole. So here is angle SRQ. Now, what is the definition of sec? Remember, sec is a reciprocal of cos. Now, if sec is a reciprocal of cosine, so remember the definition of cosine is what? is adjacent over hypotenuse. So that means if you are looking for sec, the definition of sec will be hypotenuse over adjacent. So which is equal to, from that angle that I have highlighted here, so my hypotenuse is 10, and then my adjacent will be the side that is closest to this angle is 6. So the answer here will be 10 over 6. And then we are done with question 2. Let's move to question 3. In the sketch below, triangle MNP is drawn, having a right-angled triangle at N. So as we can see, the angle here is 90 degrees. MN is equal to 15 units. So we are given MN as 15 units. A is the midpoint of PN. So A is the midpoint of PN. That means this side, AP, is equal to A is equal to AN. Now, angle AMN is 21 degrees. As we can see, this angle here is 21 degrees. The first question here, we are required to calculate AN. What is the length of AN now? So to calculate AN, we can see in this triangle, in triangle MAN, this triangle here, we can see that from the angle that we are given, we have adjacent side, and the side that we are looking for, which is AN, is opposite. So now that means we can use tan. So we know that tan, okay, we know that tan of angle 21 degrees is equal to opposite. Opposite is AN that we are looking for, over adjacent. Adjacent is what is 15, the side that is given. And then from here we multiply everything by 15, or we just cross multiply. So we are going to have AN multiplied by 1, which is AN, is equal to 15 multiplied by tan 21 degrees. So now this will give us our AN as 5, it will be 5,776. So here we have 5,76. Even here we are going to have 5,76, because we are told that AN is the same as AP, since A is the midpoint. Now, the whole side here will be 11,52. Will be 11,52. Now let's move to the next question, B. We are required to calculate angle PMN. So where is angle PMN? Let's see. We are required to calculate PMN. So we are looking for this angle as a whole. Now in this bigger triangle, which is triangle PMN, we can see again that we do have, from the angle that we are looking for, that we are required to calculate, we can see that we do have our adjacent side, which is 15. We also have our opposite side. So our opposite side is PN, so which is 11,52. So now opposite and adjacent, we can use tangent. So we can use tan. So here we are going to say tan of an angle that we are looking for. Tan PMN is equal to opposite. What is my opposite? 11,52. 52 over adjacent. What is my adjacent side? It is 15. Now we are going to look for arctan of these. So that means the angle that we are looking for, angle PMN, is equal to arctan of 11,52 divided by 15. Remember, arctan means on your calculator you will press shift and then you press tangent of that value. Now this is equal to, if we calculate this, it will give us 37,52 degrees. So that is angle PMN. So this angle here, the entire angle, this angle here is 37,52. Okay. Next question. So we are required to calculate the length of MP. Where is MP? Let's check. So MP is the hypotenuse of the bigger triangle, of triangle PMN. So now we can see here that we do have the length. We do have the length of PN. We do have PN. We do have MN. And our triangle is a right-angled triangle. So we have this. Here is our triangle. So we have 90 degrees here. We have 15 here. And then we have 11,52. And then we are looking for this length. So we can use Pythagoras theorem. So the Pythagoras theorem states that the square of the hypotenuse. So the square of the hypotenuse, our hypotenuse is MP squared, is equal to the sum of the squares of other two sides. Other two sides are MN all squared plus PN all squared. This is the same as 15 squared plus 11,52 all squared. And then from here, our calculator will give us our MP squared as 357,357,71. And then we are not looking for MP squared, but we are looking for MP. So we are going to put a square root on both sides. So our MP is equal to 18,91. 18,91, that is your MP. So here you can even use ratios. Remember, we do have this angle here as 37,52. So you can use ratios to calculate MP, but even Pythagoras theorem will work because you do have two sides. So only one side is missing in a right-angled triangle. Let's move to the next question. Question 4. Question 4, we are given 4 cot of angle theta plus 3 is equal to 0. We are told that theta must be an angle from 0 to 180. So use the sketch to determine the value of the following. Do not use a calculator. If they are saying to you, do not use a calculator, there's no way that you will buy a calculator and then not use it. But you need to be very smart about it. So the teacher must not see that you have used a calculator. How? Do not take your answers to decimals. Do not take your answers to decimals. The minute you take your answers to decimals, and then teacher will see that you have used a calculator. You can use a calculator, but you need to be very, very smart about it. So your teacher must not pick it up. So now, let's see. So here, they are saying to us we must use the sketch. So the sketch must be involved here. But before I even use the sketch here, so every time when you are given this nature of question, make sure that you write this ratio as the subject of the formula. Make sure that the ratio is the subject of the formula. So here we are going to have 4 cot of angle theta plus 3 is equal to 0. We are going to transpose 3 and then divide by 4. So we are going to have our cot. So that means our cot here it's not, it should be cot. Okay, let me fix it. So we are going to have cot theta is equal to, if you transpose 3, it will be negative, and then divide by 4. So our cot theta is negative 3 over, it is negative 3 over 4. Now, you need to remember the definition. What is the definition of cot? Remember, cot is a reciprocal of tan. So the definition of tan is opposite over adjacent. So that means that the definition of cot will be adjacent over opposite. So now or you can say this is x over y. Remember your definitions, you need to know them using a right angled triangle. You also need to know them using a Cartesian plane, where you define your ratios in terms of x, y, and r. In a right angled triangle, you define your ratios in terms of hypotenuse, adjacent, and opposite. Now, here we can sketch. Our diagram will look like this. Now, number 1, we can see that cot is negative. Where is cot negative? Remember, cot goes with tangent, or goes with tan. So where tan is negative, cot is also negative. So cot will be negative in the second quadrant, as well as in the second quadrant, as well as the fourth quadrant. However, if you read here, we are told to look from 0 and stop at 180. So we know here that we have 0 degrees. Here we have 90. So 0 to 90, and then 90, here we have 180. So our terminal arm will be in the second quadrant, where I have double tick. So number 1, I said cot is negative here in the second quadrant and fourth, but we are looking from 0 to 180. So we will never reach the fourth quadrant. So our terminal arm will be drawn in the second quadrant. So let me draw the terminal arm. Here is the terminal arm. So our angle here is angle what? It is angle theta. So every time when you complete this right angle triangle, so your vertical line must go towards your x-axis. So here you'll have 90. And then now, what is our x? X is negative 3, and x is negative in the second quadrant. What is our y? Or what is our opposite? Our opposite is 4. What is it that is missing here? We need to find the value of the hypotenuse, or we need to find the value of r. So we can use the Pythagoras theorem to find the value of r. So we know very well that r squared is equal to x squared plus y squared. Now, this is equal to, we do have our x as negative 3 all squared, plus we do have our y as positive 4 all squared. And then from here, we will get 25. This is r squared. And then we put a square root on both sides. R is always positive, so r is equal to 5. Now we have our r as 5. Now we do have our x, we do have our y, we do have our r. Now we can calculate anything. Once you have your x, your y, and r, you can calculate anything. The first question here, we are required to find the value of cos theta. So what is cos theta? You need to remember the definition. So the definition of cos, you can say it is adjacent over hypotenuse, or you can say it is x over r. Now, what is our x here? Our x is -3. And then what is our r? Our r is 5. So that means cos theta is -3 over, it is -3 over 5. And then b, we are required to find the value of cos squared, not cos, but cosec. It's cosec squared theta. You need to remember the definition. Remember the definition. Remember the definition of cosec. Or cosec is the reciprocal of sine. So now that means cosec is the same as what? It is the same as hypotenuse over opposite, or all squared. Remember, or you can say it is r over y all squared. So this is equal to, now what is our r? Our r is 5. What is our y? Our y is 4 all squared. So the answer is 25 over, it will be 25 over 16. The answer here will be 25 over 16. And then number C. Number C, we are given 3 multiplied by sine of angle theta, sec of angle theta divided by tan of angle theta. Now, we are going to solve this. This is the same as we have 3. Now, what is the definition of sine? It is opposite over hypotenuse times, what is the definition of sec? Remember, sec is the reciprocal of cosine or of cos. Now, so that means sec will be hypotenuse over adjacent, all divided by, what is the definition of tangent? What is the definition of tan? So the definition of tan, it is opposite over adjacent. And then now substitution. This is equal to 3. Now, what is our opposite? Remember, opposite is the same as y. So our opposite here, it is 4 over, what is hypotenuse? 4 over 5. Into 5, what is adjacent? -3. All divided by, what is opposite? It is 4 over, what is adjacent? -3. Now, from here, we can simplify. We can see that 5 and 5 will divide. 3 and 3 will divide. So in the numerator, we will remain with -4. And then divided by 4 over -3. And then we can change this division to multiplication. So this is equal to -4 times -3 over 4. Now you can see that 4 and 4 will divide, and then -1 multiplied by -3. So answer here is positive. It is +3. So the answer is +3. Let's move to question 5. Question 5 is similar to question 4, but the fortunate part with question 5, the diagram is already here. The diagram is already drawn. So if the diagram is already drawn, so we don't need to worry about the quadrants. Okay? Now, let's see here. In the diagram below, we are given the point. Remember, the point is always x and y. We are given the point, which is point P, which is x and y, is the point in the third quadrant, as we can see here. Here is that point. ROP, this angle here, is equal to beta, and we are given 17 cos beta plus 15 is equal to 0. Remember, every time when you come across this nature, you need to make sure that this is the subject of the formula. So we are going to transpose 15, then divide by 17. So that means here, our cos beta is equal to negative 15 over 17. Remember the definitions now. So the definition of cos is x over r, or you can say it is adjacent over hypotenuse. So here we do have our x. Our x is negative 15. We do have our r. Our r is positive 17. So before we do anything again, we need to make sure that we complete this to make a right-angled triangle. Remember, when you construct here, your construction must always go towards the x-axis. So it will be 90 here. So we have our x is negative 15, or we have our adjacent, and then we have our r is equal to 17. We just need to calculate y, or our opposite. So we calculate y using Pythagoras theorem. So r squared is equal to x squared plus y squared. Now we do have our r, which is 17 squared, is equal to, we do have our x, which is negative 15 all squared plus what, plus y squared. Now we are going to have 17 all squared brackets minus negative 15 all squared is equal to y squared. Now this will give us a 64 is equal to y squared, and then we are not looking for y squared, so we are going to put a square root on both sides. So y is equal to plus or minus 8. But now, because we are in the third quadrant, y is negative, so our y here is not positive 8, but our y will be y is equal to negative 8. So now let's answer the questions. We have our x, we have our y, we have our r. Remember, once we have your x, your y, and r, you can now answer any question. So now let's see. So the first question is, write down the values of x, y, and r. So we said our x is negative 15, our y is equal to negative 8, and then our r is equal to 17. And then we are done with A. And then let's move to B. Without using a calculator, determine the value of the first question. We are looking for sine of angle beta. So sine beta, and then definition, we know it is y over r, or you can say it is opposite over hypotenuse. So now what is our y? Our y is negative 8. What is our r? Our r is 17. So the answer here is negative 8 over 17. So this is your solution. So sine beta is negative 8 over 17. And then B, Roman figure 2, cos squared 30 multiplied by tan beta. So with this one, remember 30 is a special angle. So you need to know cos 30 by heart. But if you do have a K-show, worry not. So K-show will help you. So what is cos 30? Cos 30 is square root of 3 over 2. Because they is squared, so you just say all squared. Multiply by, what is tan beta? Remember the definition of tan. It is opposite over adjacent, or y over x. So now what is our y here? Our y is negative 8 over, what is our x? Our x is negative, it is negative 15. So this is the same as 3 over 4 multiplied by we have 8 over 15. Now we can see here that 4 can divide into 8 how many times? 2 times. But 4 can divide into 4 only once. And then 3 can divide into 3 once, but 3 can divide into 15 5 times. So here you have this as 1 times 2 over 1 times 5. So the final answer here, it is 2 over. The final answer will be 2 over 5. So that is your final answer, 2 over 5. And then the last question, we have cot squared beta. Remember the definition of cot. Remember, cot is the reciprocal of tan. So cot is the reciprocal of tan. So that means here you have adjacent over opposite, or it can be written as x over y. But remember, it is squared, so you just put squared. So that means this is equal to, now what is our x? Our x is negative 15 over, what is our y? Our y is negative 8, all squared. And then this will give us, I think it is 225 over 64, if I am not mistaken. So you have your 225 over 64. Okay, let's move to the next question. Question 6. Again, question 6 is almost the same as question 5. Even here, the diagram is already drawn. You don't need to worry about quadrants. We can see the diagram is in the second quadrant. So we are given our x. Remember, the point is always x and y. We are given our x as 5. We are given our y as 12. So y is 12, x is negative 5. We need to complete our diagram first. Remember, when you construct, you go towards your x-axis. So we construct, we put 90 here. And then we can see that the only thing that is missing in this, it is r. So how can we calculate r? We use Pythagoras theorem. So r squared is equal to x squared plus y squared. Now, this is equal to, we do have our x as negative 5 all squared, plus we do have our y as 12 all squared. So this is equal to, our r squared is equal to 25 plus 144, so which will be 169. So this will give us 169. And then we put the square root on both sides because we are not looking for r squared, but we are looking for r. So our r is equal to 13. Remember, r is always positive. So r is equal to 13. Once you have your x, your y, and r, you can now answer any question. So now let's see. So the first question here, we are looking for cos theta. What is the definition of cos? It is x over r, or you can even say it is adjacent over hypotenuse. So now what is our x? Our x is negative 5. What is our r? Our r is 13. So that is your answer. So the answer here, it is negative 5 over 13. And then b. Let's move to b. B, we are given cosec. Remember, cosec is the reciprocal of sine. So now remember, what is the definition of sine? Sine is y over r. So that means cosec will be r over y all squared. And then plus what? Plus 1. This can be written as hypotenuse over opposite. It is still fine. Now, what is our r? Our r is 13 over, what is our y? Our y is 12. All all squared, and then plus what? Plus 1. So now here we have 169 over 144 plus 1. So what is 169? This is the same as 169 over 144. 1 can be written as 144 over 144. So this is equal to, we already know here that we have 144. If you do not have a calculator, so you can just keep one base. 144 plus 169. It will give us 313. So we have 313. So the final answer here, it is 313 over 144. Now let's move to the next one. Special angles. Remember, with special angles, you need to know all of them by heart. But if you do have a K-show, you need to worry not. So now, the first question here, I think this one in the test or exam, it is only 4 marks. So changing the special angles and simplifying, then you answer. So what is sine 45? So sine 45 is the same as square root of 2 over 2 multiplied by, what is tan 60? Tan 60 is the same as the square root of 3, but there is squared, you just put squared. All divided by, what is cos 45? Cos 45 is root 2 over 2. And then now you can see from here that this and that will cancel out. You are left with square root of 3 all squared. So the answer will be 3. So the answer will be 3 here. And then let's move to B. B again, same story. Now, here we are given a sine 60. What is sine 60? Sine 60 is square root of 3 over 2 multiplied by, we are given tan 30. Tan 30 is the same as root 3 over 3. All divided by sec 45. So now you need to remember sec is the reciprocal of cosine or of cos. Remember, there is no sec in your calculator. But now if you know that cos 45 is equal to root 2 over 2, and sec is the reciprocal of cos. So that means sec 45 will be 2 over root 2, because it is a reciprocal, so you just invert. And then if we simplify this here, now if you simplify this, root 3 multiplied by root 3, it will be 3. And then 2 multiplied by 3, it will be 6. Divided by 2 over root 2. And then now this is the same as 1 over 2. And then we can change division to multiplication. And then times root 2. This will be times root 2 over 2. So the final answer here, this thing gives me root 2 over 4. So that means your answer here will be root 2 over 4, if I'm not mistaken. Let me move to the next one. We are almost done. I think we are only left with one nature here, which is question 8 only, and then we are done with this. Now, here again, we are dealing with special angles. So you need to know cos 30 by heart, which is the root 3 over 2. Times, what is sine 60? It is square root of 3 over 1. Plus, what is cosec 45? Cosec is the reciprocal of sine. if you know sine 45, sine 45 is root 2 over 2. So that means cosec will be 2 over root 2. But all squared. Multiply by, what is sine 60? Sine 60, it is the square root of 3 over 2. And then again, all squared. And then from here, if we simplify this, this is the same as 3 over 2, and then plus. So this one here will give us 4 over 2. 4 over 2 is the same as 2. Multiply by, and then this one will give us 3 over 4. 3 over 4. Now, this is the same as 3 over 2 plus 2 can divide into 4, or can divide into 2 once, and it can divide into 4 twice. So now what is 1 times 3? It is 3, and then over 2. And then 3 over 2 plus 3 over 2. This is 1,5 plus 1,5. The answer will be 3. So the answer here, it is equal to 3. Now, last question, which is question 8. Let's go straight to question. Question number 8, which is the last question now. So we are required to solve these equations. So first thing first here, we need to separate. So we need to separate this sine of an angle. Remember, if we are solving these equations, we want to solve for this angle. But first thing first, we need to make sure that we separate sine of an angle. So how am I going to separate? So here, I will multiply everything by 3 first to get rid of this 3 here. So if I multiply everything by 3, I am going to remain with 4. Sine of an angle is equal to 3 multiplied by cos 37 degrees. And then on both sides, I am going to divide by 4. So if I divide by 4 on both sides, I will have sine of an angle is equal to 3 multiplied by cos 37 degrees, all divided by what? All divided by 4. I have divided everything by 4. Now, I want to solve for this angle. So, to solve for an angle, we are going to have angle theta now that we are looking for is equal to arc sine. So, arc sine means I am going to press shift on my calculator first. And then I am going to put all this, which is 3 cos 37 degrees, all divided by what? All divided by 4. So that means angle theta is equal to, so my angle theta here will be 36, comma 7. It is 36,796,66, and then which is the same as 36, 880. So in 2 decimals degrees. So that is your angle theta. It is 36,80 degrees. And then B, let me move to B. We have 2 multiplied by sine of an angle. Here is your angle. And then plus 1. We need to make sine of an angle subject of the formula first. So that means we need to separate this. A sine of an angle. And then you can see that 1 is outside the bracket. So first thing first, I need to transpose this one. So if I transpose 1, I am going to remain with 2 sine of an angle, which is theta plus 15, is equal to this minus 1. It will be 1, comma 462. And then I still need to separate because I still have this 2. So I will divide everything by 2. So if I divide everything by 2, I will have sine of an angle, which is theta plus 15, is equal to 1, comma 462 all over 2. Now I can solve for this angle. This is the angle. Now I am going to have theta plus 15 is equal to arcsine. So arcsine means I will press shift first. 1, comma 462 divided by what? Divided by 2. So now theta plus 15 is equal to, now what is arcsine of all these? So the arcsine of all these will be 46, comma 97 02. And then we transpose 15 to remain with theta on the left. So I'm going to have 46, comma 9702 minus 15, which will be 31, comma 97. So that is my angle theta. So theta is 31, comma 9,97. And then let's move to C. C is straightforward. So we have tan of an angle. So my angle here is x. So we just say x is equal to arctan. And then we have 2, comma 2, 2. So now x is equal to, now what is arctan of 2, comma 2, 2? It will be 65, comma 75. And then we are done, degrees. And then even this one, we have arctan of an angle. This is an angle. You cannot separate it for now. So that means we are going to say 2x is equal to arctan of 1,19. So 2x is equal to, what is arctan of 1,19? It is arctan of 1,19. Let me see calculator. Where's my calculator now? So we have shift tan 1,19, which is equal to 49,95 845, and then we divide by 2. So divide everything by 2. So that means our x here is equal to 24,98. And then we are done with this one. Let's move to E. Let's move to E. E, we are given this is sec of an angle, which is x plus 10, is equal to 5,759. So now with this one, first thing first, we know that in the calculator there is no sec, but we know that sec is the reciprocal of cosine, or it is the reciprocal of cos. So this can be written as, this is the same as cos, and then we have x plus 10 is equal to, since it is the reciprocal, we'll just write it as 1 over 5,759. And then from here, we can find this angle here, which is x plus 10. So we are going to have x plus 10 is equal to arc cos 1 over 5,759. And then now we are going to have x plus 10 is equal to, now what is arc cos of this? So it will give us 80. So this is the same as 80. Now to solve for x, we transpose 10. So therefore, our x is equal to 80 minus 10, which will be 70 degrees. And then we are done with E. Let's move to F. F again, we can see that we need to separate this ratio first. So we need to write this ratio, sine of an angle, as the subject of the formula. So before we do that, we need to transpose these two. So if I transpose 2, I am going to remain with sine of an angle over 0, 2 is equal to transpose 2. It will be 1,24 plus 2, which will be 3,24. And then multiply everything by 0,2. Even here, I multiply by 0,2 so that this and that can cancel out. And then I will remain with sine of an angle is equal to 3,24 multiplied by 0,2. It is the same as 0,648. So this is 0,648. And then I will find my x as x is equal to arc sine 0,648. So x is equal to, now it will give me 40,39. 40,39. And again, you need to make sure that your calculator is in degrees. At the top there must be small d representing degrees. So your calculator must be in degrees, otherwise you will get wrong answers. And then let's move to G very quickly. So here we are given 4 multiplied by sec of an angle minus 3 is equal to 5. First thing first, we need to separate. We need to make sure that this is the subject of the formula, sec of an angle. Now I'm going to transpose 3 and divide by 4. So I'm going to have a sec of an angle, which is 10 plus x, is equal to 5 plus 3 will be 8. So I will have 8. If I divide on both sides by 4, I will have 8 over 4. So here we have sec of an angle, which is 10 plus x, is equal to 1 over, it is equal to 1 over 2. Now again, you need to remember, it's not equal to 1 over 2. 8 divided by 4, it is the same as 2. Now, remember 2 is the same as 2 over 1. Now, you need to remember that sec is the reciprocal of what? It is the reciprocal of cos. So, of cosine. So now, we can write this as cos into 10 plus x is equal to, now if it is the reciprocal, now it will be 1 over 2. And then from here, we can now say 10 plus x is equal to a cos, and then of 1 over 2. So now this will be 10 plus x is equal to, and then a cos of 1 over 2 is equal to what? Is equal to 60. And then if we transpose 10, we are going to have our x is equal to 60 minus 10. So x is equal to 50 degrees. And then we are done. So after you have watched this video, just go to past papers, do all the past papers, and then you will be able to get that 40 marks for trigonometry. Remember, this is the first part of trigonometry, which is plus or minus 30 marks. You still have trig functions where you need to sketch and interpret the graphs. But these, or what we have discussed so far, can give you up to 30 marks. So please do not forget to share, like, and subscribe. Thank you very much for watching. I hope it helped you a lot. It did help you a lot. I hope so. Thanks.